everyone. I'm Alka Priya, sub-editor at TimesTech Print Media. Today we have Dr. Dinesh Ramanathan, CEO from NexGen Power Systems for this exclusive interview. Before I start our conversation, I would like to tell about Mr. Dinesh Ramanathan. Dr. Ramanathan is one of the founders of NexGen Power Systems. Prior to co-founding NexGen Power System, Dr. Ramanathan was the CEO of Avogi Incorporation, where he oversaw the development of vertical gallium nitride technology to build power transistors. Now, I would like to start with the questions. So, my first question to you is, kindly share an overview, key focus of your company.
The key focus of our company is to make the most efficient, smaller size, and lighter power systems in the world. So let me start off by explaining what a power system is. So currently we are using a laptop to have this call. All laptops have a little power supply that you plug into the wall so that they can charge the battery that comes along with the laptop. So I have one such power supply, which I'm just going to show you on the screen right now. And this is the power supply that my laptop is using in order to charge the battery that comes with the laptop. The size of this charger is determined by the switch that's actually in it. So the switch that's in it is made out of a material called silicon. We're all familiar with the silicon transistors. They're kind of part of our everyday lives. What we have done is we have actually created a new transistor. It's made out of a material called gallium nitride, and that allows us to put significantly more power into this charger. So let me show you the charger that we have, which is the NexGen charger. This is the NexGen charger. It has 240 watts worth of power in it. This one is 87 watts. So if I just put the two of them together, you can see that we are typically giving you 3 times more power in the same volume. So this is what we do. And as the power becomes larger and larger, we can actually make these power supplies become smaller and smaller. And that's the real big focus of the company.
My next question is to you. How your company works on power transformation and how useful is it in today's world?
Right. So I just showed you what these power systems do. They actually allow us to convert power from the wall socket into power that's used by all electronics, and it allows us to, in the same form factor that you use today, give you roughly 3 times more power than what you have right now. And the advantage of something like this is you can charge your laptops faster. The same thing applies to electric vehicles, where an electric vehicle is nothing but a battery that's running on wheels, and such a battery needs to be charged. With our technology, you could charge the electric vehicle battery significantly faster, because in the same form factor, you could get 3 times more power.
So my third question is the benefits of gallium nitride and how is the company using this novel compound to offer next-gen solutions?
Thank you. That's a very good question. So one of the properties of gallium nitride, especially the type of gallium nitride that we make, which is slightly different than most of the other gallium nitride devices in the marketplace, is that we can run these gallium nitride high voltage devices at very high switching frequencies. It means we can turn on and off these gallium nitride switches at frequencies that are 10 times more than the frequencies that you run today. The devices that I showed you that are in the power supply that I showed you earlier are running at 1 megahertz switching frequency. The current devices that are made out of silicon typically run at about 100 kilohertz. So we're running 10 times faster. And that's why we're able to shrink the size by roughly 1/3 compared to what's available in the marketplace today. In addition to having that gallium nitride transistor that runs at high switching frequencies, we also have to redefine the power supply, because not all power supplies can scale with the current technology. So when you introduce a gallium nitride device in your power supply, you have to rework all the algorithms that go around that power supply so that they all can run at this high switching frequency as well. This is what we've done as a company. And all this work in making the systems that go around that gallium nitride device is all done in our Bangalore office over here. The vertical gallium nitride devices that we make, they're actually made in our factory in upstate New York. And I'll show you what a gallium nitride wafer looks like over here. So I don't know if you can see this, but this is a gallium nitride wafer. And one of the devices of the gallium nitride wafer, I don't know if you can see it clearly here, is a really, really small one. So a silicon device that performs the same as this will be 20 times bigger than the size that you're seeing over here. And these devices are what go into the power supply that I showed you. All the algorithms, the system design, the software, the hardware, the mechanical engineering, all that we have put together is done in our R&D office in Bangalore. In addition to that, we actually also manufacture this entire power supply with our contract manufacturer based out of Chennai, and we ship worldwide from Chennai. So this is a unique company where we manufacture things in the United States, Semiconductor. We actually manufacture the systems and we build the systems in India, and we ship these world-class systems to customers all over the world.
So I'd like to know about the importance of vertical gallium nitride and your key focus and benefits.
Thank you. So vertical gallium nitride is a unique technology. It is the technology of the future. It is what I consider will be prevalent, and be the dominant transistor that we will see in the marketplace, over the next 5 to the next 50 years. Vertical gallium nitride is unique technology. Our company has over 100 patents on the way the gallium nitride technology is used and created. And this technology allows us to improve the efficiency of power supplies pretty significantly. It also allows us to reduce the size and weight of these power supplies. And that is the contribution that vertical gallium nitride would make in this market. So where all power supplies get used in laptop chargers, like I showed you. They get used in motor drives. They get used in data centers. They get used in electric vehicles. They get used in LED drives. So power supplies are pretty much prevalent everywhere, and they're in all walks of life that we see. So this technology will be prevalent and will be influential in all walks of life, especially where there's power conversion.
Great. How far your company has reached and been successful in power transformation in India?
So most of the work, like I showed you, of the power supply is actually being done in India. So this power supply is state-of-the-art power supply. There is no such power supply like this anywhere on planet Earth. And these power supplies are actually designed and manufactured in India. The design happens in our office in Bangalore. In Bangalore, we have engineers that do hardware design, software engineering, power electronics, mechanical engineering, validation and test. And we put this entire system together, or these specialities together, to actually make that power supply. And we also manufacture the power supply in India itself. So these are, as I said, state-of-the-art manufactured, state-of-the-art power supplies, which are designed and manufactured in India.
Okay, so my next question is, design advantages of using gallium nitride in a case where wide bandgap semiconductor designing cost is said to be much higher than traditional silicon.
Yeah, no, that's also a very good question. So this is what I call one of the myths in the marketplace. So it's very important to understand, like I was showing you the device size earlier, the common misconception is that the silicon or the gallium nitride wafer, which I showed you, is more expensive, which it is, because it runs in much lower volume than the silicon wafers run today. However, as I also pointed out, the die size or the die of the device that we end up using is 20 times smaller than that of silicon. So because our devices are so much smaller, we actually get a lot more devices per single wafer, and our costs are relatively comparable to that of silicon. That's number one. Number two, when we make the power supplies, and these power supplies are 50% smaller, we are using lesser material, lesser plastics, lesser PCB space, lesser potting compound, all these things contribute towards lowering the cost of that entire system itself. Not just that, using lesser material means that we're actually being as friendly as we can to the planet, because when those power supplies are obsoleted, we're not throwing away a whole lot of unnecessary materials as well.
Okay, so can you please tell me about your company's expansion plan in India?
Sure. So like I told you, the first product that we're making is a 240 watt power supply. It's this power supply that I showed you earlier. Our technology is also set up in a way in which we can take two of these power supplies, combine them together and make a 500 watt, three of them and make a 750 watt, four of them to make 1 kilowatt power supplies. 2 kilowatt power supplies are what go into electric bikes and electric scooters right now. So this technology is very scalable. And once the technology scales, we can actually take it in very many different directions. So currently we have a team that's been working on the 240 watt power supply and some of our LED power supplies. We expect the LED portfolio to grow and expand pretty dramatically. We expect this portfolio to grow and expand as well into various verticals, which I talked about earlier, especially in data centers and in the automotive space. And for that, we would be hiring and growing our team with the people that I talked about before. So we're always looking for hardware engineers, software engineers, mechanical engineers, validation engineers, power engineers, all to come in and work together to create this platform of a power supply, which allows us to scale from the 240 watt to 5 to 6 kilowatts worth of power.
Okay, so I would like to know your viewpoint on manufacturing of semiconductor in India, and where do we stand?
Yeah, so now that's a very interesting question as well. So I fundamentally do think that semiconductors should get manufactured in India, and I think the most recent semiconductor manufacturing what do you call incentive scheme that has been put forward by the government is actually a good first start for attracting some semiconductor talent into the country. I think one of the things that people tend to forget about semiconductors, or they don't know about semiconductors, is that you need significant amount of infrastructure to be able to make semiconductors. This infrastructure includes having a fabrication facility. So just to give you an example, our fabrication facility in upstate New York is 20,000 square foot from a clean room perspective. It sits on a 14-acre lot. It's a 66,000 square foot facility with a 20,000 square foot clean room. Clean room basically means that it's an environment in which you don't have any dust particles or any kind of contaminants that actually can deposit themselves on the wafer that I showed you. Because even the smallest contamination can actually cause the wafer to not produce the type of parts that you're working with. You also need what is called DI water or deionized water. You need vacuum, you need air, compressed air. There's a bunch of basic infrastructure that you need in order to be able to set up a very simple semiconductor facility. And then the equipment that you put into the facility, the people that run those equipment need to be trained on those equipments. There's a lot of infrastructure work that has to get done. And all these things typically require a significant amount of capital and a significant amount of expertise. So the capital is what the government is basically subsidizing at this point in time. It's very important to make sure that the expertise gets developed inside the country. And the best way to do that is to typically set up a small fab so that the total expense isn't as high as setting up a much bigger fab, building up the expertise, training up the people, and then setting up a second one so that now you have a second fab that you can run with. So I think the program that's there today, that's been put forward by the government, it's actually a very good starting point. But the key point here is going to be, it's not just capital, is also going to make sure that we have skilled engineers that are capable of running the equipment, running the facilities, and making sure that the processes are in place to actually produce the kind of transistors and semiconductor systems and integrated circuits that will actually come out of these factories. So I don't know if I hope I answered your question, but without quite answering it,
Yeah, your all questions were. So thank you so much, Dr. Dinesh Ramanathan, for adding all the relevant points with us. So with this, we come to the end of this interview session. I would like to thank you, Dr. Ramanathan, for deliberating the insightful knowledge and all the thrown questions. So once again, thank you, sir, for joining us.
No, it's completely my pleasure. Thank you for taking the time, and I hope that this interview and is educational to most people.